Good morning, geometry students, and welcome to Virtual Geometry with Mr. Watkins or Coach Watkins. I'm glad you're watching this. I hope that you are all still happy and healthy, and I hope you're having a good, great, grand, wonderful day. This is gonna be a brief video walking you through an idea of similarity in geometry. And when we think of the word similar, it's funny, I'm really sad because this is one of my favorite days in class that we get to talk about this, because I love asking, what do you think the word similar means? And most people would say, well, the word similar means, kind of alike. Like if I said, well, here, let me go ahead and draw something. If I said, well, here's a flag, I'm going to draw a flag. Ooh, oh, my flag got weird. Okay, hang on. So let me draw a flag. And I say, and then I'm going to try to draw another flag, and I'm going to try to make it look just like that. And I go, okay, so I draw a flag and go, woo-da-da. And if I said, are those flags that I've just drawn, are they identical? Well, of course not. They're not identical. But someone would easily say, no, but I think that they're similar. And I think that they would go along with that. Yeah, we go, yeah, they're similar. But the funny thing is that is not what we're talking about. See, similarity in geometry is completely different than similarity in the rest of the world. See, similarity in geometry class is right here. Similar in geometry class refers to two things. It refers to when you're talking about similar shapes, similar polygons, but similarity in geometry class refers to two specific things. That if you have similar polygons, the corresponding angles are congruent. Okay? The corresponding angles are congruent. Now, you might not know what this means yet. You might be a little bit confused. I might have jumped too far. Don't worry, I'm gonna catch up. But when we're talking about similar polygons in geometry class, corresponding angles are congruent. And corresponding sides, and this is a good one. We go, okay, so corresponding sides are, big word, proportional. Okay? Corresponding angles are congruent and corresponding sides are proportional. Now let me show you what I'm talking about. I've got an example right here, okay, of these two shapes. Now this symbol going on in the middle, ABCD is, and there's this little caterpillar crawling, EFGH. That is the symbol for similarity. Okay, it's like the top of a congruent symbol without the equal sign below it. That literally says ABCD is similar to EFGH. And so as we look at these two figures, we go, they are similar. By definition, that means that they include these two things. They include first, that the corresponding angles must be congruent. And secondly, the corresponding sides are proportional. So as we look at these two shapes, we go, okay, see this angle up here must be congruent to this angle right here because we were told the corresponding angles are congruent. And then also we say this side right here must be proportional to this side right here. In the same way that this one is proportional to this one. In the same way that this one is proportional to this one. In the same way that this one is proportional. Ooh, it's gone. In the same way that this one is proportional to this one. Okay? And so we got to keep coming back to these two ideas. Similar polygons in geometry class refer to polygons whose corresponding angles are congruent and whose corresponding sides are proportional. Now, what I want to do is I want to walk you through three brief examples that'll get you going on understanding this stuff a little bit better, okay? And they all come from this picture right here. We're dealing with figure ABCD and figure EFGH, and we're dealing with the fact that they are similar, meaning that they have congruent corresponding angles, they've got proportional corresponding sides. So let's walk through this and let's take a look at some of the things that you can solve with similar polygons, okay? So exemple numero uno is right here. And exemple numero uno says find the measures of angle E, F, and G. Okay, well, E, F, and G are all on this smaller polygon, the smaller quadrilateral, and our job is to find the measure of angle E, find the measure of angle F, and find the measure of angle G. Well, this is really simple because we know, I'm basing this all off the fact that these two figures are similar. So when we go and look at this, we go, wait, similar figures have congruent corresponding angles. So that means angle E corresponds to angle A. So therefore, the measure of angle E is equal to the measure of angle A. And we know what the measure of angle A is. So I can say the measure of angle E is equal to 72 degrees. And this would be my final answer right here. Okay. If I look at F, okay, we go, the measure of angle F has got to be, we look at that one, we go, wait, I don't know what B is. How am I supposed to do F? Well, let's come back to that one. We'll talk about it in a second. And let's get to the measure of angle G. The measure of angle G is, well, G corresponds to C. So we know it's going to be the same as the measure of angle C. We know that the measure of angle C is 68 degrees. So therefore, the measure of angle G is 68 degrees. So we got our final answer on that one. Now I look at this picture and I say, okay, wait a minute. Now I know that if H is 105, then that must mean that D is 105. But I still don't know B or F. And then I remember, wait, whenever I have a four-sided figure, I know that all four angles must add up to, and the answer is 360. If you don't remember that, you can say, well, that comes from that n minus 2 times 180 formula, n being the number of sides. And so I said, well, I've got four sides. I subtract 2, and I multiply it by 180, and that just gives me 2 times 180. So the sum of the interior angles is 360. I know one of the angles is 72. I know another one of the angles is 68. And I know another one of the angles is 105. So how do I figure out what B or F is? Well, I can just add these others up and take them away from 360. So you go, okay, I've got 72 and 68 and 105 and 2, 8, and 5 is 15. And 1, 7, and 6 is 14. And that gives us a total of 245. And when we subtract 245 from 360, we're going to get 115. So the measure of angle F has to be 115 degrees. And there's our final answer. Okay, so all of this came from the idea that similar polygons have congruent corresponding angles. Well, let's look at exemple numero dos. Exemple numero dos has to do with finding the length of sides that we don't otherwise know. It says find the length, remember if it doesn't have a line segment above it, it's the length of, find the length of BC and the length of EH. And we can do that because we know some of the lengths of these figures. And we know that in similar polygons that corresponding sides are proportional in length. So let's take a look at this, all right? So what I'm going to do is I have to set up a proportion just like we did yesterday. All of that work yesterday was not for nothing. That was to help us get really good at that idea of cross-multiplying and solve. And so that's what we're doing here. So what I need to do is I need to say, well, let's see, 4 right here, the length of AB is a side I know. And right here, 3, EF is another side I know. Those two sides correspond to each other. So that's how I can start my proportion. I could say 4 is to 3 in the same way that, I might say, well, in the same way that BC is to FG. Okay, AB is to EF the same way that BC is to FG. 4 is to 3 the same way that BC is to FG. And so then I can fill in. I go, wait, I don't know BC, but I do know FG. So I can say 4 is to 3 the same way that BC is to 6. And I can cross multiply and solve. And I said, well, that would mean that 3 times whatever BC is would be equal to 24. Divide both sides by 3, and I would get that BC must be equal to 8. It's 8 units long. Okay? Now, I can set up the exact same proportion to solve for EH. And I'd say, well, I'm going to start with that idea as 4 is to 3 in the same way that, and now I look and go, where's EH? Well, EH corresponds to AD. So I'd say 4 is to 3 the same way that AD corresponds to EH. And I know the length of AD. The length of AD is 6. So I say 4 is to 3 the same way that 6 is to EH. And from here, I can cross multiply. And if I cross multiply, I get 4 times the length of EH is equal to, well, 3 times 6 is 18. And if I divide both sides by 4, then I get that the length of EH must be 4.5. It's that simple. So what you have to do is you first have to set up a proportion that works. Remember, compare corresponding sides. Okay, notice I started with the larger one and then went to the smaller one. And so right here, when it says 4 is to 3, that was larger is to smaller. And then BC is to FG, that was larger is to smaller. I have to keep that running the same way. All right, last example. Exemple numero tres. An exemple numero tres, this is the easiest in the world. It says find the similarity ratio of ABCD to EFGH. And we haven't talked about this idea. What in the world is a similarity ratio? Well, a similarity ratio is just this. It's how big is one compared to the other. And how you figure that out is you just compare two corresponding sides. So the similarity ratio of ABCD to EFGH is 4 to 3. That's it. I'm done. That's all you have to do. Because similarity ratio is just comparing one to the other. Now, had it asked for what's the similarity ratio of EFGH to ABCD, hopefully all you would realize is you go, wait, well, that would mean I'm comparing the small one to the big one, so that would be 3 to 4. I just spin it around, okay? All right, well, my hope is that you're understanding similarity in polygons and what that means. And we know that similarity in polygons in geometry class refers to that the corresponding angles are congruent and the corresponding sides are proportional. All right, if you look, right now is posted a small and brief assignment to go along with this. There'll be an answer key corresponding to that, and you all should have no problem working through these. I hope you have a good, great, grand, wonderful day. Thank you.